How does it feel?
It's very sour.
Is it very sour?
Sour. It's very sour.
How sour is it? Can you describe it? What makes it so sour? Many things we taste are acidic in nature, such as vinegar, lemon, yogurt, and soft drinks. Common examples of alkaline materials are soda powder, kitchen cleansers, drain clearers, and glass cleaners. So, what is an acid and what is an alkali? When we say something is acidic, how acidic is it? And how alkaline does a substance have to be for us to consider it alkaline?
We can't always tell by our sense of taste whether something is acidic or alkaline, as not everything is edible. Some substances may even be toxic. Not only that, different people may respond to the same substance differently. So it's important for us to have objective and scientific means to test for acids and alkalis.
The simplest way is to use litmus paper. There are two kinds, red and blue. Acidic materials turn blue litmus paper red. Alkaline materials turn red litmus paper blue. Alternatively, we can test by using litmus solution. For example, if we add drops of hydrochloric acid to blue litmus solution, the solution turns red. On the other hand, the alkaline sodium hydroxide solution will turn red litmus solution blue. As both litmus paper and litmus solutions can indicate whether a substance is acidic or alkaline, they are referred to as indicators. Another common indicator in the laboratory is phenolphthalein. This is colourless when affected by acidic or a neutral substance, but turns pink when it comes into contact with an alkaline material. However, neither litmus nor phenolphthalein tells us the degree of acidity or alkalinity of a substance.
We have to use other indicators to check the degree of acidity or alkalinity. This is the universal indicator. It's a mixture of several indicators. We can add drops of the universal indicator to solutions with different degrees of acidity and alkalinity and observe the change in colour. Scientists have developed a scale of pH values ranging from 0 to 14 to indicate the degree of acidity and alkalinity of substances. pH 7 represents neutral. That means the substance is neither acidic nor alkaline, but lies between the two. pH values lower than 7 indicate acidity. The lower the value, the more acidic the substance is. On the other hand, pH values higher than 7 indicate alkalinity. The higher the value, the more alkaline the substance. pH value can be expressed in decimals. Moreover, pH 0 does not mean there is no pH value. Instead, pH 0 indicates an extremely high degree of acidity.
Normally, the universal indicator is used with reference to a colour chart. This enables us to check the pH value of a substance by comparing the colour of the mixture to the chart. Therefore, if we want to determine the pH value of a substance, we can mix it with the universal indicator or soak pH paper made from it. Then, by checking it against the colour chart, we know its degree of acidity, or alkalinity.
For solutions with extreme pH values, the colours shown by the universal indicator are less clear. So we usually use the colour chart to check up to pH 11. Besides, judging the colour simply with the naked eye is not very reliable. A pH meter is designed to measure the pH values of substances. This digital pH meter can measure very accurately. Let's take a look at the pH values of the following substances. Some plants can also be used as acid and alkali indicators. This is red cabbage. If we place a leaf in warm water, we see the natural colour of the leaf. However, its colour changes according to the pH value of the medium. The leaf of red cabbage can be called a natural acid and alkali indicator. The flower of the hydrangea plant can also be used as an indicator. If we plant hydrangea flowers in mud with different pH values, their colour changes. If we place a petal of the flower into an acid, its colour changes slowly.
Many everyday examples of acids. For example, lemon and grapefruit contain citric acid. Yogurt contains lactic acid. Tea leaves contain tannic acid. Apples contain malic acid. And vinegar contains acetic acid. Many sour fruits, such as grapes, grapefruit or lemon, contain citric acid. Compare these fruits with less sour fruits, and they are more resistant to bacterial decay.
A major cause of food decay is the activity of microorganisms. Microorganisms can't easily survive in an acidic medium. Therefore, food with higher acidity turns bad less easily. Less sour vegetables like cucumber and carrots can be preserved with vinegar. Vinegar not only adds to the flavour of the food, it also helps prevent food decay.
The appetizers provided in restaurants are prepared by this method. Preserving vegetables with acid is part of the culinary culture in many countries. All the acids in the food we mentioned earlier are edible. They are weak acids. However, not all acids are edible. Acids commonly used in laboratories, namely sulfuric acid, nitric acid, and hydrochloric acid, are not edible. They are comparatively strong acids. Strong acids are very useful both in everyday life and in industry. For example, in the process of electroplating, many such acids will be used. Some cleansers contain hydrochloric acid, while car batteries contain sulfuric acid. There are many examples of alkalis in everyday life. Many household cleansers contain alkalis. For example, floor and glass cleaners contain aqueous ammonia, which is a weak alkali. Clog removers and drain cleaners contain solid sodium hydroxide, which is a strong alkali. Sodium hydroxide is such a strong alkali that it is highly corrosive. When dissolved in water, it releases a large amount of heat. The hot alkaline solution quickly dissolves substances like hair or fat that may block the drain, enabling liquid to flow through the drain freely. Common alkalis used in the laboratory are aqueous ammonia, sodium hydroxide, potassium hydroxide, and calcium hydroxide. Strong acids and strong alkalis are highly corrosive. Their concentrated solutions are especially harmful. Some of them may emit pungent fumes when the bottles containing them are opened. If we drop concentrated sulfuric acid, for example, onto a piece of fabric, it burns a hole. So we should always exercise extreme care when handling strong acids and strong alkalis. They should be stored in the lower shelves of the cabinet to avoid any harmful destruction that could be caused by spilling from higher positions. Gloves must be worn when using them. To avoid inhaling the fumes or burning your skin, do not place them close to your face. They should only be used in places with good ventilation. The procedure of diluting a concentrated acid or alkali is very dangerous. Accidents will occur if you don't handle the liquids carefully. When water is poured into a concentrated acid or concentrated alkali for dilution, a large amount of heat is released. The heat quickly turns the water into steam, and the steam, combined with the concentrated acid or alkali, will splash. It is dangerous. Hence, during dilution, we should take a small amount of concentrated acid or alkali and pour it slowly into a large mass of water. Keep on stirring so that the heat released is dispersed in the water. This bottle of vinegar contains acetic acid. Pour it into a glass and place an egg in it. What happens? Small bubbles appear where the egg is in contact with the vinegar. What change is taking place? What gas do the bubbles contain? Keep the egg in the vinegar for a day and see what happens. Wow! The egg loses its shell completely. We see only the egg white and the barely visible egg yolk inside it.
We can offer a scientific explanation for the change. A chemical reaction has taken place between the eggshell and the vinegar. A gas is released, and the eggshell dissolves, until finally it looks as if it has disappeared. People usually say that the eggshell has been corroded by the vinegar. Eggshells are composed mainly of solid calcium carbonate, while vinegar is made up of acetic acid. When the two substances come into contact, a chemical reaction occurs. This produces water, calcium acetate, and carbon dioxide. As the calcium acetate is soluble in water, it looks as if it has disappeared. And the bubbles we see in the experiment contain carbon dioxide gas.
You can test the gas to see if it is carbon dioxide in this way. Collect the released gas and add it to lime water. The lime water turns milky, indicating that the gas is carbon dioxide. The shells of many animals, just like eggshells, are also composed of calcium carbonate. They react with dilute acid in the same manner. That is, the shell surface is corroded away while carbon dioxide is released. Many construction materials, such as marble, limestone and gravel, contain a large amount of calcium carbonate. They can be corroded by dilute acids and release carbon dioxide. That's why cleansers with acid components must not be used to clean marble surfaces. The previous experiment shows us that dilute acids can corrode substances containing calcium carbonate.
Dilute acids don't just corrode substances containing calcium carbonate. They also corrode metals. Some metals react with dilute acids, releasing a colorless gas. This gas is hydrogen. Place a burning splint near the test tube and see if there's a pop sound. This is the method for testing for hydrogen.
It is a Chinese tradition to cook ginger and pig's trotters with vinegar to celebrate childbirth. Ceramic utensils are used for the cooking. Metallic utensils are not used because the acid in vinegar could corrode the metals. Rainwater is acidic in nature. Air contains carbon dioxide. When rainwater drops from the sky, it absorbs carbon dioxide from the air. The carbon dioxide reacts with the rainwater to become carbonic acid. Normal rainwater usually has a pH value of around 6.5, which is slightly acidic. However, the air in some places is highly polluted. Exhaust fumes from factories and vehicles contain large amounts of acidic gases, such as sulfur dioxide, carbon dioxide, and nitrogen oxides. When these gases dissolve in rainwater, they increase the acidity of the rainwater substantially. As a general rule, rainwater with a pH value lower than 5.6 is referred to as acid rain. As acids corrode construction materials like marble and metals, acid rain damages the structure of buildings and can ruin sculptures with considerable artistic or historical value. It also affects the environment in which water creatures live. Besides, even the growth of plants is affected as the acid deteriorates soil quality. Therefore, we should do our best to protect the environment and to avoid polluting the air.